Earthquake, a natural disaster that has affected many countries and states. This is a huge problem that is affecting some countries, especially the low income countries, and one of them would be Philippines. These pictures are all taken in Manila, Philippines of what the earthquake has done to their country. Now, I'll be talking about the problems that are affecting Philippines by the cause of earthquake. The reason why earthquake occurs is when tectonic plates are being released into an energy. Earthquakes are most likely to hit places that are surrounded near the ring of fire. Countries that are in or near the ring of fire are the countries that are most likely to be affected by earthquake. The reason why it hit Philippines is because the ocean's crust is being crashed into the continental crust. The bigger arrows shows the direction of the Philippine Sea Plate, the Pacific Plate, and the Eurasian Plate, where the ring of fire is situated at. And this is how the ground under the Earth looks like. The lithosphere, which is the rigid outer part of the Earth, is 80 kilometers wide. The mantle is 2,800 kilometers from the Earth ground, followed by the core, which is 3,500 kilometers deep below the mantle. The core consists of the metallic liquid outer core, which is 2,300 kilometers, and the solid inner core is 1,200 kilometers deep, right below the metallic liquid. This picture shows the residential building damage risk. It shows the different states of Philippines that are getting affected by the number of buildings that are either low or high at risk, and this shows how earthquake has affected the buildings in Philippines. Since the problem in this country is reconstructing buildings, by building an earthquake-proof building, it will help the country a lot. These are some images that shows how badly the buildings have been affected. Earthquake can damage a building or bridge when the material used to build the structures is not strong enough to withstand the earthquake, and this happens. Another reason could be the preparation of the country. The country may not be prepared for such natural disasters, as it may not have occurred at that certain area, thus buildings were not built to be a certain natural disaster proof. This shows what happens when earthquake is occurring. Some scientific principles that would have been caused in the past would probably be compression, as the force from the ground and from the top of the building would push into each other and the building would be squeezed from forces from the top of the building and the bottom of the building that can cause the building to collapse.
This is one of New York's skyscraper. It's called the World Trade Centers. Now this one is called Library Tower. It was built in Los Angeles, California. John Hancock Center was built in Chicago, Illinois. Now this skyscraper is called the Empire State Building. It was also built in New York. This last skyscraper is called the Petronas Tower. It was built in Kuala Lumpur, Malaysia.
Isolation bearings is something that will be constructed as the base. It helps to keep the building from falling when the earthquake happens. The damage of the building will be decreasing during the earthquake too.
Rubber bearings are placed between the bottom of the building and its foundation. The bearings carries the weight of the building. That is why the bearings are designed to be very stiff and strong for the vertical load. However, they are designed to be weaker for the horizontal loads, so that they can be moved sideways during the earthquake. Here's what happens to the rubber bearings as the earthquake happens. Another type of isolation bearing is called the friction pendulum bearings. They are designed to be very stiff and strong for the vertical load, so that they can carry the weight of the building. However, when they slide it means that the earthquake movements will occur mainly in the bearings. It is also placed between the bottom of the building and its foundation. This is how diffraction pendulum bearings works.
To keep the building from swaying, there will be a strong core in the center of the building, which is called tune mass damper, also known as the harmonic absorber. It helps to reduce the vibration of the structure.
Vertical structural system is made up from columns, beams, walls, and bracing. They transfer the sideways of forces on the building to the ground. The vertical structural systems included brace frames, moment-resisting frames, and shear walls. Shear walls will be constructed as a rigid vertical diaphragm capable of transferring lateral force from the outside walls, floors, and roofs to the ground foundation in a parallel direction to their planes. Vertical truss or reinforced concrete wall are the examples. To keep the building from tearing apart, strengthen the frame by attaching or placing a rigid wall inside it to maintain the shape of the frame and to prevent rotation at the joints. What is a brace frame? Brace frames uses trussing to resist sideways force on buildings. It also helps stabilize the frames against the sideways forces from earthquakes and strong winds. Brace frame example is cross bracing. It is when the two diagonals are used to form a cross bracing. This type of brace only resists in tension. The reason to this is because one of the brace is in tension for the sideways force in one direction on the frame, while the other brace is in a tension when the force is reversed. Another type of brace frame is called single diagonal. If this is used, it must be able to resist tension and compression that is caused by sideways forces in both directions on the frame. This is an example of brace in compression. And this is an example of brace in tension. These are other types of brace frames, such as inverter V bracing, K bracing, and knee bracing. The connections between columns and beams are designed to be rigid. The columns and beams bend during earthquakes. These structurals are designed to be strong in bending. So basically, it means that this frame is the frame that resists the force by bending. Here is an animation of the moment resisting frames. Horizontal structural systems are usually constructed for doors and roofs. They help share the sideways forces on the building between its vertical structural members. The two things that is included are diaphragms and trussing. Horizontal diaphragms are usually floors and roofs. When a diaphragm is still enough in its horizontal plane, it can share the sideways earthquake forces on the building between the vertical structural members, examples such as the columns and the walls. Another type of horizontal structural is called horizontal trussing. It is usually used in roofs where there is not enough deck to allow the roof to act as stiff as the horizontal diaphragm. The trussing can transfer the sideways earthquake forces on the building to its vertical structure members. The examples are columns and walls.